I'm Brynhildur Davíðsdóttir, and I'm one of your hosts for this webinar on subnational applications of ecological footprint and biocapacity. I'm a professor at University of Iceland, and I'm a co-director of the International Ecological Footprint Learning Lab Partnership, or the IFO partnership, as we call it. And whether you're joining us from your home, office, or wherever you happen to be, we're thrilled to have you here with us. And everyone participating in this event is either a current or a potential future member of the IFO partnership. And with attendees from various organizations and places, it is really inspiring to see such a diverse group of people interested in using and increasing the applicability of the ecological footprint and biocapacity. But before getting started, I'm going to take a moment to introduce the speakers we have today. And all of our speakers have done exciting work with footprint metrics and are members of the IFO partnership. So beginning with Peter Victor, he is a co-director of the IFO partnership and a professor emeritus at York University, Canada. He is a well-known scholar in the field and, for example, is the author of the recently published book, Escape from Overshoot, Economics for a Planet and Peril. And he continues to lead research on ecological macroeconomics and the ecological footprint. Eric Miller is the director of the Ecological Footprint Initiative and a co-director of the IFO at York University. Eric manages multiple projects, including the production of the National Ecological Footprint and Biocapacity account. Peri Dworatzek is a partnership coordinator for the IFO partnership and is a PhD student at York University, and she studies community applications of the ecological footprint. She has also co-produced 3 editions of the National Ecological Footprint and Biocapacity accounts. Kiona Lo is a senior data analyst for the Ecological Footprint Initiative and the Sustainability Office at York University. She completed her master's degree in environmental studies at York University, and she has co-produced 2 editions of the national accounts. She is also working with York University's Sustainability Office to produce a 2nd edition of York University's emissions and ecological footprint data. Jennie Moore is a co-director of the IFO partnership, and she is Associate Dean of Building Design and Construction Technology and Director of Sustainable Development and Environmental Stewardship at the British Columbia Institute of Technology. And she is an internationally recognized leader on sustainability issues, for example, with focus on industry practices. And then finally, Danielle Letang is the manager of data strategy at the Rural Ontario Institute, which is a partner organization of the IFO partnership. She has led the Rural Ontario Institute Community Wellbeing Data Dashboard project, which is meant to provide information and evidence for local decision-making. And she has been working with IFO to develop the ecological footprint and biocapacity accounts for over 500 municipalities in Ontario, Canada, which she will talk more about later in her presentation. But before passing the mic over to our presenters, I'll briefly share how we've structured this webinar today. Our agenda will start with an introduction from Eric Miller to the topic of subnationally scaling the ecological footprint and biocapacity. And then following this, we will dive into 3 distinct examples of how subnational scaling of footprint assessments has been applied in the IFO partnership. Jennie will showcase examples of geographic scaling done at BCIT on urban footprint analyses. And Kiona will share an example of an ecological footprint being applied to an institution. And Peri will share examples of household-level community assessments of the ecological footprint. And then after the 3 examples, we will hear from Danielle about her experience in working with the IFO partnership in creating the Ontario Municipal Ecological Footprint and Biocapacity accounts. These presentations, they will cover about first half of the webinar, and then for the second half, Peter will moderate the discussion. And I want to emphasize the importance of the discussion because it will help us gain valuable information about interest from you as current or potential IFO partners. And we will also use the discussion to inform a series of methodological workshops we will be hosting in the new year that are intended to explore methodological approaches for subnational assessments. And with that, I'm going to pass this along to our speakers. Thank you.
The focus of this is, as we've titled, Subnational Applications of Ecological Footprint and Biocapacity. Another way of referring to this, let's say, is non-national applications of ecological footprint and biocapacity. Now, to contextualize this, I'll just focus on distinctions about ways of applying ecological footprint and biocapacity, the way that we have approached this as a research team and as a partnership. First, to remind ourselves, when we're talking about biocapacity, we are talking about a measure of the capacity of an area of land or water to provide a flow of biological production, which is useful to us as humans in terms of providing us with food and feed, with renewable materials, with space for our settlements and infrastructure, and to sequester anthropogenic carbon emissions. When we're talking about ecological footprint, we're talking about a measure of human demand for biocapacity. When we think about the range of applications of ecological footprint and biocapacity, one of the great virtues of ecological footprint and biocapacity is that it's broadly applicable across a range of spatial scales and different levels of aggregation and so on. Now, there's always the challenge of how does one distinguish between the various ways of applying this. And so this is the way that our research team has come up with the distinctions, which we find to be helpful because it's a good way of sort of identifying some commonalities and distinctions amongst different ways of engaging with the application. And so we can think about the applications in terms of sort of four headers, let's say, certainly national or international applications. We can also think about them, some other applications as non-national, but spatially related. We can think about applications relating to enterprises, and we can think about applications relating to communities. And so to distinguish this further, when we're focusing on national applications or international applications and the work of the National Ecological Footprint and Biocapacity accounts, that's of course relating to nation states that have national statistics, which of course is quite distinct relative to the other components here. When we're focusing on spatial applications, these are defined by geography. And so you'll hear from us examples of applying this on a geographically specific basis. And that can be, let's say, at the level of cities that are defined by geographies. They can be potentially on the basis of watersheds, which are geographies defined by biophysical elements. It can also be on postal codes, et cetera, something with a defined aspects of geography. When we're thinking about applications at the enterprise level, we're using the word enterprise in a broad sense, but other words that you can use in this realm can be like corporations, for examples, or non-corporate entities, or even if they're formally in law regarded as corporations, things like universities, for example, or pensions. And so they're defined by law, and then they interact with others through contracts and so on. And so their relationships to others are defined by things like supply chains and contractual arrangements and so on, as quite distinct from, for example, spatial and international ones. Focusing on community, we're sort of using the word community in a broad sense here to identify one or more humans with aspects in common. So we're thinking about, for example, communities of people who are united by a common faith or maybe ancestry, for example. You can think of a community of people as being students in a class. We can think about a community as being those within a household, whether within a household they are legally related to each other or not, is just as roommates, for example. And so we think it's helpful to make these distinctions. And so the webinar today will focus on all of these components beyond the national level there. And it's important to think about these distinctions along several lines. So one is in terms of data that is available and or necessary. Each one of these sort of realms of the applications is very has different challenges and opportunities associated with that, in the same way that the tools and the methodologies that are needed to engage with that. And so you'll hear, for example, when we're applying it on geographic bases, that's where we'll often be using tools in that realm of geographic analysis of data and so on. When it comes to things like communities, that's where we'll be using methodologies like, for example, surveys and focus groups and so on, which is not what's done on a national basis, et cetera. The capacity to engage in analysis and application varies between these. Communities don't tend to have data analysts, whereas larger enterprises do. Large enterprises can have sustainability professionals who can access their internal data. Not all of them do necessarily. Even enterprise is quite a broad collection of different forms of corporations, for example, and different sizes of them, including small sole proprietor ones that don't have sustainability professionals in them necessarily. And the significance of the application and the engagement also varies as well. Obviously, these different realms have different realms of control over things. On a spatial basis defined by geography, cities are planning the grids and the infrastructure setup and so on, which implies, of course, a stream of sort of demand from us as humans in terms of ecological footprint and effects on biocapacity, et cetera. And so that's where it's important to be mindful of all these forms of applications, because they all have different realms of significance and how to engage in that. You'll hear from us, and you'll certainly see this engaged in the literature, that results within these realms can be applied or derived across them. And there's various vocabulary used to characterize that. Sometimes you'll hear about, for example, top-down approaches, which are really meant to be disaggregating, for example, national data to apply it to specific geographies, or to have it serve as fill-in for data related to enterprises as they engage with others through supply chains and so on. In the same way that community data or even geographic data can be aggregated in order to inform other realms of applications. Final point here is that research is necessary within and across all of these. And that is certainly the focus of the Eiffel Partnership. We have research teams and a research agenda that covers this full span, and you'll be hearing about some of the research that's been underway. And of course, there's many more research questions yet to be fulfilled, for example, relating to applications at the level of enterprises, applications spatially, and same thing with applications on a community level, as you'll hear about shortly. So with that, this will help to characterize some of the examples that we'll share with the other speakers that I'm sharing here. And so next we will hear from Jennie Moore. And I will pass the virtual mic over to you, Jennie.
Okay, thank you very much, Eric. Hello, everybody. It's a real pleasure to be here. So we don't have much time, so I'll just hop in very quickly with the urban methodology approach that I developed under the leadership of my PhD supervisor, William Rees. I was a graduate student at the time that the ecological footprint was being developed originally with Mathies Wackernagel. I was doing my master's then and worked for 10 years in municipal local government and always wondered why local governments weren't working with the ecological footprint. So I developed a novel approach to ecological footprinting that does not use the national accounts. Next slide, please. It's based on energy and material flows. So I undertake an urban metabolism for cities based on organizing the data, because I was at Metro Vancouver, the first air quality planner in charge of climate action, the first demand side management planner in charge of helping reduce energy materials demands in the region. So I had the knowledge of how cities organize their data, and I organized the data that way. So looking at the tons of liters of materials that are flowing through the city, the gigajoules of energy by different energy types, and then the land that's being used, and converting that into both greenhouse gas emissions for operating and embodied energy and materials, and then associating in the ecological footprint. So I do use the equivalence factors, which are derived from the national accounts, but that's the only connection with scaling from the national accounts that's used. Next slide. So the component structure that I use for this integrated urban metabolism based on energy, material flows, and life cycle analysis is to look at materials, embodied energy, operating energy, and built area. And for every domain of consumption, I apply these 4 different lenses, and I'm looking at them in the residential, the industrial, which is the small bracketed I, and then commercial and institutional. And the reason it's ecological footprinting is consumption based. So we're not counting things that are manufactured in the region and exported. So that's why the I is bracketed. It's only trying to capture the things that are localized for consumption. Next slide, please. And so here's the data inputs and outputs and the domains of consumption that I work in. And these are organized the way that municipalities manage their resource flows for demand management, at least in British Columbia, where I'm from. And so this is made in Vancouver, originally for Vancouver and Metro Vancouver, and now being used across the province. So it's food in terms of metric tons of food by food type, buildings in terms of materials by material type, energy measured for electricity in kilowatt hours, and natural gas by gigajoules. And increasingly now we have different forms of energy with photovoltaics and renewable natural gas and wood. Consumables and waste by metric tons of material by material type. And this is based on a forensic waste audit. So we look at what's in the waste stream and then reverse engineer back what the energy material inputs are. Transportation by materials and the vehicle kilometers traveled by different forms of vehicles. And then finally, water, and we're looking at the infrastructure. So it just says liters there, but we also look at the infrastructure, the embodied energy of the infrastructure in the system, as well as the operating energy. Next slide, please. And so originally I piloted the research with my first proof of concept was with Metrovan, but then I applied it for my PhD with the city of Vancouver, who, because they were able to see a pathway to interpreting the data based on their own data, and that was a big challenge for the municipalities. They don't understand a lot of the economic input-output table data, and so it's a black box for them. But because I could show them how it was their data, simply transformed stepwise into an ecological footprint, they were far more amenable to it and agreed to adopt a lighter footprint goal in their Green City initiative. And so it was my research that was supporting the tracking of that goal for several years. Next slide. Other applications, now that we have the city data, we can apply it to communities and neighborhoods. So Project Green Block was 20 households in a neighborhood in Vancouver. Because we had the Vancouver city footprint, now we can start to extrapolate by individuals and modify by different household incomes. But what I never really look at income, I'm always looking at actual material consumption. So 20 households tracked their food, did an assessment of their homes, tracked their energy usage, their kilometers traveled by vehicle type, and we customized their footprints for them across these 20 households. And over 3 years, they looked at ways to reduce it. And I think the biggest thing, that, although they did reduce their footprint, some households went up, the majority of the block went down. They said the best thing that came out of this was a community of social cohesion. They really felt this. Next slide. And so now we work with over 30 municipalities across the province, but it represents over 80% of the provincial population, because we work with all of Metro Vancouver and the Capital Regional District, as well as other municipalities. So now the province of British Columbia is interested in working with us to adapt this for all municipal use, but that would be on a proxy basis. So the municipalities that are highlighted are the ones for whom we've actually done the urban metabolism study and converted into a greenhouse gas emission inventory and ecological footprint. Going forward, we are going to be creating proxies. So if you're in a certain regional area, you can assume the basic footprint and then adapt it based on the municipal data that the municipality has. So we'll be able to have 100% coverage by proxy data. But these are the ones that we've actually done. They represent rural and urban, northern, and more southern or central. True North BC we haven't done. And then the last thing I'll just say is what's really driving this is actually not the ecological footprint, but because we can derive a greenhouse gas emissions scope 3 and embodied emissions.
I'm going to talk about the institutional level of the application of the ecological footprint. On the institutional level, an example that we want to share with you is the work that we have done for York University. So for this project, we started with estimating York's greenhouse gas emissions, and then we used emissions and the expense data to derive York's ecological footprint. So in terms of the framework of the emission inventory, we follow the Greenhouse Gas Protocol, which is a recognized standard for greenhouse gas emission accounting in organizations, in which we quantify the emissions for all three scopes of them. So we had scope 1 emissions, which were the direct emissions that were produced on site and by York's assets. Example of this would be the emissions generated from the cogenerator. And we also have scope 2 and scope 3 emissions. These are the indirect emissions that are produced because of the activities of York, but not generated on site or under York's direct control. So scope 2 are the ones specifically from purchased energy, or in this case, purchased electricity. Or scope 3 are the rest of the indirect emissions. So for scope 3, we adopt our own components to the ones that are most relevant in a university setting and the ability for university to affect changes. So an example would be the procurement emissions, which is something that we derive using the expenses of York universities, and the commutes by driving emissions, which were derived from the parking permits data. So after we're done with quantifying York's greenhouse gas emissions, here is how we quantify York's ecological footprint. Next slide, please. So first, we converted all the greenhouse gas emissions into the forest carbon uptake component of ecological footprint. And then we converted York's expenses into the 5 remaining components of footprint using the consumption land use matrix table. So this table was derived from the Ontario report of ecological footprint, which is essentially translate $1 of expense into units of footprint components based on the sector where the expense was incurred. Now, on the other side, on the biocapacity side, they were derived from the area of the 3 York University campuses, the Kew, Glendon, and the one in Costa Rica. And then if we go to the next slide, we can see the results of York's ecological footprint and biocapacity. So here we can see that the largest component of York's ecological footprint is the forest uptake component, which accounts for around 80% of York's ecological footprint. It is followed by another component of the forest, which is the forest products component. As for York's biocapacity, it's actually the area that is covered by the York's logo on the tree map, which is on the top right, in scale to its ecological footprint. So from this map, we can see that only around 1% of York's ecological footprint is covered by its biocapacity, which in other words, it means that York University requires about 85 times its biocapacity to meet the demands on nature. Now, so this is what we have done for at the institutional level for York University. So now I'm going to pass it over to Peri to talk about the community level.
Thanks, Kiona. So I'll share the third example. Oops, we'll go back one. Which is what we called community applications. So this includes groups of people that aren't necessarily defined or separated by a certain geographical boundary. And so that's why we use the form of an ecological footprint calculator to find the ecological footprint of the various households or individuals that make up that community. And then we can aggregate it together to find the footprint, the ecological footprint for the community as a whole. And so I'll showcase 2 examples of ecological footprint calculators that have been created in our ecological footprint initiative. One was this calculator on the screen for a Métis-focused ecological footprint calculator that was developed for the Métis Nation of Ontario. That's an Indigenous community in Ontario. And the other calculator was for a group of Toronto parishes. So I'll start with this Métis Nation calculator. This is just a screenshot of the initial web interface when people log on to start the calculator. And you can tell it has a beautiful web interface, and they contracted out a web designer to do this. And this would also be an example of what we would call a synchronous calculator. So when people fill out the survey, they fill out the calculator, then their results are given to them right when they're done. So here's an example of some of the questions that were asked in the calculator. And just to emphasize the level of detail that we can get down to when we use a footprint calculator. So this asks about how much money was spent on food within the household for that week. And then it's split up into different food categories. So there's breads and cereals, animal meat, fish and dairy. And so we'll share the other calculator as well. And so this is a screenshot of the calculator that was developed for the group of Toronto parishes. And this is what we would call an asynchronous form of a calculator. So people would fill out the survey and then they would get their footprint results at a later date. And that's maybe not as fun for the people filling out the calculator, but it is it works exactly in the same way, and it's easier to set up because we can set it up with something as simple as a Google form. So here's some examples of what this survey, what this ecological footprint calculator asked people. So for example, what their type of primary residence is and how many square feet of living space that residence has, as well as the desired temperature on the thermostat and what type of thermostat was being used in that household. So again, really emphasizing the level of detail that we can get down to when we use an ecological footprint calculator. So I've shown these two examples. I'm just going to share some results of the footprint calculator that was done for the group of Toronto parishes. So this graph is comparing the ecological footprint of the different community members, so the different households, starting from the lowest ecological footprint on the left, going up to the highest ecological footprint. And you can see it's split up into different categories of consumption. So the 6 categories of consumption on the top are household consumption, so things that the community members have control over, whereas the bottom 5 are government and infrastructure consumption that they don't have control over. But you can see even within a community that arguably these people could live similar lifestyles, they have similar values, they might live in similar places. You can see there's still quite a bit of variability between the consumption happening within this community. In total, there are 27 households that did the calculator. And if you were to take the top 26 households and reduce their ecological footprint to the lowest level that was already achieved within that community, then 248 global hectares would be saved each year. The final graph I'll show is breaking down the various consumption categories for an average member of the community. Construction is one of the largest components, but it is not within the control of the household, whereas food, services, utilities are some of the other largest components that could be within control of community members could make decisions over as they are thinking about their household consumption. And so with this data, it's possible to provide empirical recommendations for the community member to have recommendations or solutions to reduce their ecological footprint. And so as I continue into the PhD program, this is where I will be taking my research. I'll be working with communities to create calculators, provide empirical recommendations, and then also try to understand if there's been behavior change or why not there hasn't been behavior change. So I'll pass it over to Danielle now to talk about an IFO partner success story.
So we were really happy to work with York University to develop some indicators for a broader project that we are working on, which is to develop a dashboard that features indicators for rural community well-being. And so we did this work over the last 2 years, I guess I'd say, and we are now presenting the results of this work on the dashboard, which just launched last month. So it is now freely and publicly available on our website. And so it does show ecological footprint and biocapacity indicators for all communities. We did publish a summary report that shows results just at the rural and urban level. Peri developed a more detailed methodological report that has all the details about how we did this. And for future work, we'll be looking at updating these community accounts and mobilizing knowledge. But I just want to give you a quick look at what the dashboard looks like. So this is how the indicators just generally are structured on the dashboard. So you can find the ecological footprint indicators on the environment page. So we've structured this to hopefully tell a bit of a story. So we have these broader categories, and then we have indicators grouped into themes, and they all help tell you what's going on with the community's well-being. So this is a screenshot of what the environment page, when you land on the environment page, this is what it looks like. So there's a map here, so you can view all the indicators spatially. And it's really interesting to see some of the regional and provincial trends when we look at the communities. You can also download some of the data if you'd like. We have a download data button on each of the pages, or you can navigate back to the main dashboard also to download the data. So once you go into the ecological footprint thematic page is where you can actually find the biocapacity and ecological footprint indicators. And we also have one here called biocapacity balance, where we basically just took biocapacity and then subtracted eco footprint, and then see what we're left with at the end to see if there's biocapacity reserve or a biocapacity deficit. And I should note that we are showing all of these numbers as per capita, so global hectares per capita, just to make the comparisons between communities a little bit more fair. And we also have some contextual visualizations here to show the breakdown of the different components of ecological footprint and biocapacity, so that you can see how each of those components contributes to the overall numbers. And then in addition to that, we also provided a breakdown of the different categories of ecological footprint consumption. So you can see a little bit of what Peri was talking about here. So, the government and fixed capital consumption is not really within a community's control, but the household consumption is. And so then we've provided an even more detailed breakdown of what that looks like, so people can understand exactly where their consumption is coming from. And that's it for me. So I'll pass it back over now. Thank you.
Okay, well, on behalf of the all the participants in this webinar, let me thank all the speakers for those great high-level presentations. I say high-level, they were in fact quite detailed, but they do give us an understanding of the scope of possible subnational applications. And I hope that the presentations have sparked interest amongst the participants here, and that you have questions that you would like to pose to the presenters. With that, I think it's time to say goodbye, and do watch for the newsletter and visit the EIFL website. We are making an increasing effort to communicate better with members of the partnership, and to help members of the partnership communicate among themselves about these issues of common interest relating to the ecological footprint. So thank you for your participation, and we will be in touch.